Hello students, this is a review for exam 1 for college physics 1301, but it's going to help anybody studying basic physics. And this is over Newton's laws, motion in one dimension. So that's what it is. Okay, so let's go there. Here is the question, first one. You have a mass of 2 kilogram and two forces are acting on it. One is a 3 Newton force acting to the west, and another is a 4 Newton acting to the south. So the two forces are at right angles to each other. And you're asked to find the acceleration of the mass. So the question is, what is the acceleration of the mass? Whenever you see forces, mass, and acceleration, you know we have to use Newton's second law, according to which acceleration is net force divided by mass. So when you say net force, in this case, you can't add them, you can't subtract, because they are at right angles. You have to find the vector sum. Net means vector sum. So for that, we have to use the Pythagorean theorem. When you use that theorem, you know it's square root of the sum of the squares of both, which will give you 5 Newton. Because this is 16, this is 9, so 25, square root of 25 is 5 Newton. Once you get that, plug it back into this relation, and you should be able to find the acceleration from that relation. So it's 5 Newton divided by 2 kilogram, which is 2.5 Newton per kilogram. But you know, Newton per kilogram is basically the same as meter per second squared when you break the Newton into its kilogram meter per second squared. So okay, that's what you get. So it could either be in Newton per kilogram or meter per second squared. Both of them are the same. Takes us to number 2. This is more a conceptual question. You're looking at an object moving in a circular path. And let's imagine that it's moving at a constant rate. So you have like a string with a stone at one end, and you're just rotating it with the same rate. That means, let's say it's moving at 3 meters per second. So 3 meters every second. The speed is a constant. But the question is velocity constant? So now you got to think about speed and velocity. Speed is a scalar. That means it has nothing to do with direction. It's just a number. Speed is a number. What's the speed of the object? It's 3 meters per second. That's it. Velocity, on the other hand, is a vector, which means it has a number which we call the magnitude. That's the meaning, magnitude, and we have direction. So here's the diagram I've drawn. Assuming that you are rotating it in the counterclockwise direction, the direction of the velocity at each point is along the tangent that you draw. So when you look at the diagram, you see that since the tangent is in different directions at A, B, C, and D, that obviously means that the direction is continuously changing. That means even though the speed is a constant, velocity changes, because speed is a scalar and velocity is a vector. Okay, brings us to number 3. In number 3, you have two forces again acting on an object. This time you have to find the mass of the object, but the acceleration is given. Not only that, you see that the forces are not acting at right angles. One is acting to the right, the other is acting to the left. You know, right is positive and left is negative. So when you try to find the net force, what is it? Net force is 15 minus 10. So 5 Newton to the right. That's the net force, 5 Newton to the right. Once again, you use the formula that we used before. Acceleration is net force by mass. The acceleration is given, so plug it in. 2.0 meter per second squared is, we just found the net force, 5 Newton divided by the unknown mass. Do the algebra, rearrange it. If you want to put a 1 here and cross multiply, that's fine. Multiply that with 5 and this with 2, 5 times 2. You can do it either way. And mass times 2, I mean. So mass times 2. And so you will get the mass as 5 divided by 2.0 kilograms. Because again, when you break this unit, you're going to get this cancel out as I've shown. You will get kilograms. Okay. So that's question number 3. All right, let's go to question number 4. In question 4, you have an object, let's say a car, moving at 10 meters per second. And brakes are applied. So a constant braking force is applied. Not the sudden braking, just a constant braking force is applied, bringing the car to a stop. And what we need to find is how much distance will it move before it stops. So at this point, you started applying the brakes consistently, and then it moved delta x before it stops. How much did it move? The mass of the car is given. So kinematics comes in here. So since you have the initial, the braking force is also given. Braking force is 1,000 Newton. So the braking force will be given as 1,000 Newton. But you have to put a negative. You know why? Because the braking force is an opposing force. It is opposing the motion of the object. So that's why you put a negative. Because the object is moving that way, but the force is opposite. That's why a negative. And the mass is given. So once you have the force and the mass, you can find the acceleration. Just dividing the force by the mass. Since both are 1,000, I got to put negative there. So since both are 1,000, you're going to get negative 1 Newton per kilogram. So you got negative 1 Newton per kilogram or meter per second squared. Same thing. Once you get that, use the kinematics formula. Now, which formula should you use? You are allowed to use the formula sheet, but you have to look at the equation or the formula that has the final velocity, the initial velocity, the acceleration, because we have the acceleration, and of course delta x, because that's what we're trying to find. This is the only equation that has those 4 quantities. Look at it. There's no time in it. We have nothing to do with time in this question. We're not asked to find time. We're not given time. So that's how you know which formula to use. You have to carefully list them down, including what you're trying to find. There's no other way. And then plug it in. When you plug in the numbers, you get 0 is equal to 10 squared plus 2 times negative 1 delta x. 10 squared is 100. And this is like negative 2 delta x. Well, add 2 delta x to both sides. So that'll cancel out on the right side. And then you get 2 delta x is 100. Divide both sides by 2, which again I've not shown. Divide both sides by 2. So these 2's will get canceled out. And then you get delta x is 50 meters. So that's how you do it. It takes 50 meters for the car to stop. But I have a sub-question, or part B. What if the initial velocity was, instead of 10, what if it was 20? What if it was 20? So you double the velocity. What is the stopping distance now? Do you have to do the whole thing again? Well, you could, but you could save time. You could just look at, oh, this is the quantity that changed. The initial velocity changed. So And there is a square on that. Look at that. So instead of 10, if you have 20, this is going to become 400, correct? Because 20 squared is 400. So you can see there that this number quadrupled. It became 4 times bigger, which means when you do the math, this is going to become 4 times bigger. Now, people don't realize this when they're driving. That's one of the reasons why accidents happen. If you double the speed, the stopping distance does not double, it quadruples. All other conditions being the same, like for the same braking force, same mass and all that. So keep that in mind. Here is a simple question from chapter 1 where you talk about uncertainties. Question is, what is the uncertainty in this measurement, 5.42 plus or minus 0.10? So what you got to do here is, this is the certain part, this is the uncertain part. So all you got to do is take the uncertain part, divide by what you're certain about, don't worry about the plus minus, and multiply it with 100, that's all. So that's the uncertainty. That number divided by that times 100, when you do it, you get 1.84 and it's in percent. 1.84%. Simple? So on the other hand, if you were asked what would these numbers be, you should say, oh, it could be between 5.43 and 5.41. You understood how I got that? If you add this number to this, you get 5.43. Actually, you get 5.52. Sorry. If you add it, you get 5.52. And then if you subtract it, you get 5.32. So this number could be between 5.52 and 5.32. Ooh, I almost made a mistake there. Okay. Moving on to the next one, a very important question. Calculate the height if a rock is thrown straight up. So I had to say calculate the height of a cliff or a tower or a building. So you're standing on top of a building or a cliff and you're throwing an object straight up at 20 meters per second. And it takes 15 seconds to reach the ground. So what's the height of the cliff? So you need a diagram. So look at the diagram on the left side. So this is the cliff and you are standing here and you're throwing the rock up. So it goes from A to C, where it stops momentarily because the velocity becomes 0, and then it comes all the way down to D and then to B. That's not a negative D, that's just that point is D. Okay. And 15 seconds is the time taken for this whole journey to go up and come down. But what is interesting is you don't have to worry about how much it went up because it came down by the same amount. So when it returns to point D, the displacement is 0. Because it's supposed to be drawn straight up and straight down. I've drawn it a little off so you can see it. Okay, it's supposed to be like that. So if an object returns to its starting point, the displacement is 0. So you don't have to look at how much it went up and went down and all that. All you have to do is, excuse me, where did it start from? It started from A. Where did it finish? B. So from A to B, was it going down or was it going up? I'm not asking you whether it was actually going up. I'm asking you, looking at it from A to B, isn't it going down? Because when you move from A to B, you're actually going down, which means the displacement of this rock is negative h, where h is the height. Why negative? Because anything measured down is negative. Okay? So that's the most important thing. delta y, that's the symbol for how much it moved on the y-axis, is negative of the height. If you got that, then everything is clear. Okay, what was the initial velocity? 20. Why? Because it was thrown up, and up is positive, so that's why it's plus 20. Acceleration due to gravity is always negative. So negative 9.8 meter per second squared, and time is 15. And I wrote here, I just wanted to write it down here and say, hey, what if instead of throwing it up, it was thrown straight down? Very important. If it was thrown straight down, then we know it's going to take much less time to hit the ground. But also, you have to take the initial velocity as negative. I hope you're not confused. In this case, we're throwing it up, so it's positive 20. But if you're throwing it down, it's negative 20. And then you have the kinematic equation that involves these four quantities. You have to list it down. That's when you know which equation to use. So those are the quantities. Plug it in. You have delta y as negative h. This is 20 times 15 minus half. You know why? I just put this negative here at the beginning because this is negative and then this positive. So a positive times negative is negative. So I just did it in one step. I hope you understand that. And so first calculate this whole thing, and that gives me 1102.5. And then this is 20 times 15 is 300. So then you take 300 minus that number, you get negative 802.5. But wait, you got a negative on the left side. So if negative h is negative 802.5, that means the height is 802.5 meter. I hope that makes sense. But remember, if it was thrown down, you had to take the initial velocity as negative. Okay, here's the next one. Again, a very important question. This is to do with projectiles. So in this case, you have an object from A which is projected, means thrown at this velocity, 40.0 meter per second, at an angle of 30 degrees to the ground or the horizontal. And you have to find the distance AB. Now, in order to do that, you will have to first break this velocity into its x and y components. So that's what I've done first. The x component is always cosine if the angle is taken with the horizontal, which it will be. So it's 40 times, so the number times cosine of 30, which will give you this number. And that's because when you set up that triangle here, this side becomes the adjacent side and cosine is adjacent by hypotenuse. That's why, okay. Similarly, this side will become the opposite side of the angle, and that's how sine is defined. So you get 40 sine 30 is 20 meter per second. So anyways, first you have to break up the velocity into its x and y components. And then you have to know that the x component never changes. Gravity does not act on the x component. And if the x component of velocity does not change, then to find x, all you got to do is multiply that velocity with time. So look at that. That's what I've written. This is the only formula that will work on the x-axis all the time. So the plan is, we already know this, 20 root 3, but we got to find time. If you get the time, then all you got to do is multiply that, you get the answer, okay? But to find the time, you have to think about the y component. So let's go to this side, y. On the y side, this is the equation you're going to use, because we know that delta y is 0. Why? Because it starts at A and ends at the same level. So how much did it move along the y-axis? Nothing. Only consider the initial and the final. Remember, you don't have to consider what happened in between. I know it did go up, but it came down by the same amount. cancels out. So the net displacement on the y-axis is 0. See the 0? And this is 20. We just found it here. So you put that there, times t, which we do not know, minus, how do I get this 4.9? It's just half times negative 9.8. Half times negative 9.8. I just cut down one step. I put it as negative 4.9 t squared. So now you can divide all three quantities by t, which I have not shown, divided by t, time, and then you know that on the left side, 0 divided by anything is 0, but the t here will get cancelled, right? And one of the t's here will get cancelled, so you are left with 4.9 t negative. And I flipped the side, took it to the other side, changed the sign to positive, divide both sides by 4.9, you get the time. Once you get the time, just plug in that time here, which I've done. And this is the x velocity, and so you get the distance that it has moved. So there are multiple parts here, and you got to take a look at this carefully and understand what's going on. But these are basically the two equations that will work in this case. Hope that makes sense. All right, so I think that's all I had. Those are, I think, 6 or 7 questions. The other conceptual questions, you have taken the quizzes, you've done the homework, you've worked out a lot of problems, should be easy. Conceptual questions, give it some thought before you jump to a conclusion. Now, you don't have to show any work for conceptual questions, but for problems, you have to show all the work clearly, including the formula that you're using. Don't cut corners there. Make it neat and clean so you get the total grade, full credit. Thank you so much.